this question now, and the last part of the whole test. Ball is rolling towards Louise at a speed of 8 meters per second. It's towards her, as shown in the diagram. She kicks it and it rolls back in the opposite direction. That looks like it might be important. Change direction with a speed of 12 meters per second. Better make a note of that. The ball's mass is 450 grams and her foot is in contact with the ball for 0.10 seconds. There's quite a bit of information in there. We've got sort of diagrams to help us down here. We can see the opposite direction, can't we? Take it coming in there. Okay, so what does the question want us to actually do? The question says calculate the size, only the size, don't need the direction, of the unbalanced force on the ball. Now I can think of a couple of ways to do this. The way that's most familiar to me is F equals ma, because I think I've got the information I need. I've got the mass of the ball. I'm going to need to change that into 0.45 kgs, and I've got a couple of velocities and a time, so I think I can calculate acceleration, change in velocity over change in time. That's final velocity. It ends up at 12 minus initial velocity 8, but hang on, direction, velocity is a vector quantity, opposite direction, opposite sign, divided by the time 0.1, that was the time it took, so that's 20 now. 12 minus minus is a plus, 12 plus 8 is 20, divided by 0.1, that's 200 meters per second squared. So that's the acceleration I'm going to need over here. Whoops, what's happened to my pen here? It's decided to stop functioning as a pen for a minute. And that's equal to 90 Newton. 0.45 times 200 is 90. That was deceptively easy, wasn't it? And I'm pretty sure with all of that I've had to do a calculation down here. I've had to do a calculation over here. I've put a couple of things together. I'm pretty confident that they would give me an E for that. Now, some of you might have done it by an alternative method. Okay, and you might have remembered that change in momentum, impulse, is force times time. So force equals change in momentum over time. And you might have said change in momentum equals final momentum. So mass 0.45 times velocity 12 minus mass, initial momentum, same mass, times initial velocity, and you might have recognized that the initial velocity is minus 8 because of that direction, divided by 0.1. Okay, and if you did that, you would end up, put those numbers all into your calculator, if you can, 0.45 times 12 minus 0.45 times minus 8 equals, whoops, something went wrong there. This is doing something really funny. This has gone hypersensitive. 0.45 times 12 minus 0.45 times minus 8 equals, whoops, that's not right. Clear. 0.45 times 12 equals, I'll put in the plus 0.45 times 8 equals 9. Divide by 0.1 equals 90 newtons. It gives us the same answer as we had before. It gives us that excellence. Something very funny going on with this pen just with that. Okay, and that's the end of our test.